Welcome to today's presentation on veterinary pharmaceuticals, its environmental impacts and mitigation strategies. Today, we are diving into a crucial topic that addresses the intersection of animal health and environmental conservation. So, let's start by acknowledging the essential role that veterinary pharmaceuticals play in keeping our animal companions healthy and thriving. However, their widespread use raises concerns about their impact on the environment. And in this presentation, we'll explore these concerns and discuss strategies to mitigate them. Before we delve into the current issues, it's important to understand the historical roots of veterinary medicine. From ancient civilizations to modern advancements, veterinary practices have evolved significantly over time and shaping the way we care for animals and address health challenges. Now, let's talk about the environmental effects, about how veterinary pharmaceuticals impact the environment. These medications can enter the ecosystems through various pathways, leading to bioaccumulation in aquatic organisms and contribute to antibiotic resistance, which possesses risk to both animals and human health. Antibiotics contribute to antibiotic resistance, posing risk to human health. And it can be very difficult to treat illnesses when humans are naturally gaining more resistance to antibiotics. Specific impacts. Specifically, antibiotics used in livestock can lead to the emergence of antibiotic resistant bacteria, while hormone residues in animal products may disrupt human endocrine systems. Understanding these impacts is crucial for developing effective mitigation strategies. The next slide, we're going to discuss the mitigation strategies. So, what can we do to address the environmental impacts? Regulatory measures, best management practices, and advanced technologies all play a role in minimizing the environmental footprint of veterinary pharmaceuticals. By adopting these strategies, we can work towards a more sustainable future. Interdisciplinary research is key to advancing our understanding of these complex issues. Epidemiological studies and pharmacokinetic research and environmental monitoring all contribute valuable insights that inform our efforts to mitigate the environmental impact of veterinary pharmaceuticals. So, in conclusion, we address the environmental impacts of veterinary pharmaceuticals requires urgent action and collaboration across various sectors. Regulating oversight, best management practices, and interdisciplinary research are essential components of sustainable veterinary medicine. So, from this first part of the project, the takeaway messages are uh, veterinary pharmaceuticals are crucial for animal health, but their environmental impacts must be addressed. By working together and embracing innovative solutions, we can ensure healthier future for animals, humans, and the planet in itself. Now, we are going to start the second part of the special topics project. The second topic I have chosen is brominated flame retardants, which is also called BFRs, in electronic waste and its effects on the environment. We will delve into the historical perspective of the issue. Let's start with the brief historical overviews of PFRs. These chemicals gained popularity in the mid 20th century for their ability to enhance fire safety in electronic devices. Polybrominated diphenyl ethers, PBDEs, emerged as a dominant class of PFRs during the rapid growth of the electronic industry. However, concerns about their environmental persistence and toxicity began to surface as scientific research advanced. The environmental health impacts. The environmental health impacts of BFRs in e-waste are significant. These chemicals can contaminate soil, water, and air, posing risks to ecosystems and human populations. Bioaccumulation in aquatic organisms and potential toxicity raises concerns about the health of wildlife and safety of our food chain. Furthermore, PFRs have been linked to adverse human health effects, including reproductive, developmental, neurological issues. Challenges in e-waste management. Proper disposal of e-waste containing BFRs poses several challenges, including regulatory hurdles and inadequate infrastructure. Informal recycling practices exacerbate BFR contamination, highlighting the need for the comprehensive solution. We must address these challenges through technological innovations and policy interventions. Now we delve into the scientific study of this project. Laboratory experiments play a crucial role in understanding environmental and health impacts of BFRs. Environmental monitoring and public awareness initiatives provide valuable insights into BFR contamination and its consequences. These studies inform our efforts to mitigate risks and promote responsible e-waste management. Field studies and risk assessment help us evaluate BFR concentration in e-waste recycling facilities and predict their fate in the environment. Sampling techniques, mathematical models, and epidemiological studies provide valuable data for regulatory decision making and risk management strategies. Biotransformation of BFRs. The biotransformation of BFRs through microbial activity is a crucial process in e-waste disposal sites. Understanding these biotransformation pathways is essential for managing BFR contamination and mitigating risks associated with metabolite formation. By studying microbial degradation, we can develop effective mitigation strategies. Human exposure and health effects. Human exposure to BFRs can occur through various pathways, leading to adverse health effects such as neurotoxicity and reproductive disorders. Occupational exposure among e-waste workers and general population exposure highlight the need for protective measures and regulatory action. We must prioritize human health in our efforts to address BFR contamination. Regulation measures and industry initiatives. Regulatory measures such as ROHS and WEEE directives restrict BFR use and mandate proper e-waste recycling. Industry initiatives focus on developing eco-friendly alternatives and promoting sustainable product design. By aligning regulation and industry efforts, we can minimize BFR pollution and promote a circular economy. Technological innovations and education. Technological innovations in e-waste recycling extend producer responsibility. EPR schemes are key to reducing BFR contamination. Chemical recycling process and public awareness campaigns raise awareness about responsible e-waste management practices. Educating consumers and industry stakeholders is essential for driving systemic change. Global partnership and collaboration are essential for addressing the transboundary nature of e-waste pollution and BFR contamination. International agreements such as Basel Convention and facilitate information exchange and capacity building. By working together, we can develop holistic solutions to mitigate BFR pollution and protect the environment. In conclusion, addressing the risk associated with BFRs in e-waste requires a coordinated effort from government, industry, stakeholders, and civil society. By implementing regulatory measures, fostering technological innovations, and promoting education and collaboration, we can minimize BFR pollution and move towards a more sustainable future. Thank you so much for viewing my presentation and have a nice day. Thank you.